Yes, hello. Good afternoon, everyone. My name is Anna Bucher, and yes, connecting from Washington, D.C.
Thank you very much for overnight lecture. And how about we invite them with our greatest applause the lectures in presentation file is uploaded to our shared folder, and at the same time the link they need, because the link you will need for demo time. So I also put the links in our shared folder. So please kindly refer. And now floor is yours, Anna and Mackenzie. Thank you.
Thank you, everyone. I hope you can hear me well. And please just let me know if you have any questions. Today, we just want to make a very quick presentation, a bit about what the World Bank has been doing, supporting, not only for the process of the biennial transparency processes, but also on the policies and discussions that are building adaptation and mitigation actions in the country. So let me start by sharing my window. So please let me know when you can see it, or Mackenzie, let me know when okay, that's good. So, as I said, my name is Anna. I'm a senior climate change specialist working on different aspects of climate change, mainly the integration of climate change in planning for the World Bank and applying in different regions. I'm currently working in the Africa region. And my colleague, Mackenzie Dove, she will introduce herself afterwards, but she has been our main climate scientist working with us in the process of how to integrate climate data for climate risk assessments. So today we just want to show you very quickly what we have been doing, but also mention a very specific tool that was, this is the Climate Change Knowledge Portal, which was designed to bring opportunities in terms of understanding what the science brings in terms of climate and how we apply these different processes. So mainly, as you can see here, the World Bank has contributed to strengthening climate resilience and climate mitigation and the infrastructure working in terms of the policy through several programs. We've been really working more, the transparency related work has been focusing on building the domestic systems, the climate information, the climate information and the enabling environment. So it's really working with the different aspects of the governance, working with the different ministries to really provide more technical and financial support for things like understanding what the MRV systems is, for understanding what is options in terms of climate finance, for building green finance platform, but also working on very sectoral specific, such as in terms of forest, AFUDU, energy, transport, etc. The effort really, as the countries have evolved in terms of reporting to the UNFCCC in terms of the Paris Agreement, is really also to strengthen this overall transparency and the institutional capacity of the countries and the different ministries to allow themselves to understand the different components, of course, adaptation, mitigation, but within those, for example, how to access carbon credit markets through the forests or different other sectors, how to really be more effective in understanding disaster risk management and resilience, and how to building, for example, sustainable infrastructure. We've been working a lot with different governments on, for example, how to build platforms, not only the knowledge, but how to bring private sector, for example, into understanding where to invest and the priorities that are coming up from the national climate reports and documents. And of course, what the World Bank does is really aligning finance, and so sustainable finance to really align themselves into the processes that it really will allow the countries to access and tips to implement their adaptation and mitigation plans through NDCs, for example. So just some of the examples of our transparency support to the countries. I mean, as I said, I'm speaking both for adaptation and mitigation, but mainly is working with the institutions. One of them, for example, is the Partnership for Market Readiness, really how to support different countries, for example, the work we did with Vietnam, to really provide readiness for them to understand what a carbon market is, what is the pricing, what is the different MRV systems that need to be done, how to build baselines, how to really understand adaptation, and what is the pilot instruments that should be established in terms of getting that transparency, that reporting process, understanding the goals, understanding the updates in the NDCs or in the reporting process. This is also to bring closer the policies that are established in the NDCs, and really how to, as I said, how to really bring the elements of the new requirements in the reporting for the BORs and the BTRs, but really how to help the countries understand the data collection, the baselines, the reporting practices, and how to really bring the elements. So this is some of the examples that we've been working in different countries. But the main thing is to really have to track the different processes and the projects, and mainly how we can bring financing and different opportunities, not only at the knowledge level, but also bringing the finance the country needs to ensure that these processes are well established, are well connected, the different ministries are talking to each other to really ensure data is being shared. There is the transparency in the reporting is throughout the different ministries, and trying to really align this governance of climate in all these different countries. So what we want to today to show you, it's a little bit really focusing on adaptation part. And as we know, the adaptation component now of the new BTR is new. And I think it's where a lot of these different tools has been done. The World Bank started creating what the basis for what we are using is the understanding the risks and the risks that climate brings. And so some of the things that we've been working and aligning with the work that Mackenzie will describe later is how to build this country profiles, the climate risk profiles, that is really helping our own teams working in the different sectors to understand what climate information really is needed, how can they really build on the context, apologies, how are they able to really bring the opportunities of the exposure, understanding what is an exposure to different sectors, what is understanding the vulnerabilities, and how to start thinking about these aspects and targets and activities that means to be resilient and the adaptation context that needs to be built. So we've been doing, so if you go into the World Bank site and the CCKP, and Mackenzie will show it to you later on, we have built very numerous these profiles, and they're Word documents, but it really will show you later today how to build some of those, which bring an opportunities to understand a bit more as you go through and doing the BTRs, maybe bringing information that is not readily accessible, available, but what we're trying to do is bring the wealth of information from the science in a way that we can really bring for decision making. And one of the issues that we really need to understand is how to build for adaptation, how to build a context, but really thinking about how we can plan. And so for this, it's really important that we start thinking about the type of information that is useful in terms of climate risk assessments. And this is, understanding the context, the historical, how climate has been changing through the years, and what is our historical, what are we feeling, what is our weather, but it's also how we need to start thinking about decision making. And so not all information is the same. Not all information is useful for agriculture, for example, that needs to make decisions in the lapses of 2-3 months, to, for example, the infrastructure and really more planning into education or research that needs to be done, really integrating what is an adaptation component from a country perspective, but that is a planning that will take into the 10, 30 years or beyond. So we need to understand what are we adapting to really bring an understanding of what is our vulnerability and data and climate risks that needs to be done. And so the World Bank, in the last, I would say, 10 years, we've been trying to build different tools that really bring that concept, that really understanding what is the climate and disaster risk screening. This is just an example of many tools that we have, but how we were really trying to provide to our own teams that were doing a climate risk assessment for our own projects and with our own investments, how we needed to build not only the hard infrastructure, the hard adaptation, so what it meant for the infrastructure, the water, the agriculture sector, but what it meant also in terms of the institutional readiness. And that institutional readiness is where the monitoring, the verification, the reporting, the elements of the targets, the indicators, these are some of the elements that sometimes is not well established, is not well connected, and not so clear. And so when we have to report this to the UNFCCC and see how we are advancing towards targets, towards the Paris Agreement, and the NDCs has been a bit difficult and not very homogeneous. So these type of tools, and we have them and we'll share the link as well, provide some help of bringing that disaster and climate risk assessment and understanding the process, what it means as what we call the hard one in terms of the infrastructure and the activity that we can identify, to the more softer components, which is the institutional, the finance, and the different way of building that capacity. One of the things I also wanted to mention today is that a lot of the information that you'll see that is presented by Mackenzie today has really been useful for our own work. And this is called the Country Climate and Development Report. This is a report that is a flagship report that the World Bank has been doing for the past 4 years, more or less, which is really bringing that sense of climate and development together. So we're trying to work with the countries, doing an assessment of what it means to meet the development targets of the countries in terms of poverty reduction, growth, stability, inequality, human capital, and then how we merge it with their own policies and targets that the Paris Agreement is bringing in terms of commitments. So it's a report that we've done all the understanding of assessment in terms of vulnerability, risks, and priorities, and also in the mission, so both adaptation, mitigation components, but also understand what are the challenges that these countries are facing to meet those targets and those goals in parallel. So these reports are available. If you just country climate development reports, you can find many of them in different countries. But we'll see that we have gone through a lot of the deep dives and sectors, and the issue of data, the issue of knowledge, and the issue of information is very important. And we have a very dedicated chapter in all of them about the institutional capacity and also the finance capacity, but also the macroeconomic discussion, so the economic discussion. And a lot of the recommendations in many of the CCDRs that we call them is about improving knowledge, improving the monitoring and reporting, improving indicators, and also the governance, so the institutional transparency of how we really monitor and indicate progress. So it's just to showcase that it's one of the work that the World Bank is really doing as a flagship, and we're inviting you to look at as you do the analysis and the BTRs. So getting more specific about the tool, I'll leave the whole fun, and you'll see the great about this portal. Started around 11 years ago. It's really trying to understand a bit these projections on climate and really bring an idea about the narratives and how can we bring the narrative about the context and really understand how we can, let me put all this together, sorry, the science that we need to understand the issues, but how we can really fit for the purpose. So coming back to that time aspect that I was mentioning to you about what kind of model we use, the range of different, what we call the climate models to understand the range of options. I mean, the future is not something that we can definitely see. We don't have the way to do that, but we can understand options and scenarios. So we build a lot of different data and information to understand what could agriculture look like in the future, what could water, what could transport energy look like. And so understanding how we can make decision making, understanding the uncertainties that data can bring, but also it helps us understand how we can compare products, how we compare data, and how then science can make it useful for decision making. So the wealthness of these climate change knowledge portal, it started very simply from an Excel database. You'll see how much this have evolved in terms of visualizations. But the main goal was that we can work with the meteorological services, we can work with the providers of the data and the science and the scientific community, but then how to adjust it to developing practitioners, right? To really understand how we can homogenize and use it. The World Bank works in many countries, more than 314 countries. So we needed something that was at the tip of our hand that global data, global assessment quickly could give us that context where the countries are, and then how we can really translate. And the main thing of that is that word translation of information and data into opportunities and decision making and action. So that was the main goal of this. We've worked with many countries, and these are just some of the examples where we have used the climate change knowledge portal. So it's supporting the countries at different stages, at different requests from different ministries. But really one of the examples that we did, it was with Mexico. And so how they use the climate change knowledge data and build a country risk profile that we'll show you in a little bit, and then how they use that information to update their biennial update report. That was before this was the BTR. So we have worked on very specific sectors, so hydrological project. We work with building climate planning in general, with urban, with the forestry departments. We're working a lot with different small-sized countries, developing countries that knowledge, data, and information is a big gap. And sometimes the teams and the ministries and the representatives, it's hard to have that available for all the type of information and planning and targets that you need to build, or how to identify the adaptation action that is important. So we're trying to facilitate. We're trying to facilitate also that understanding how knowledge and information is very important. So how then the countries can also build and establish their own systems. And we also really working again, we're supporting, as I mentioned, the climate change, this country climate development report. We're really working on terms of the education and capacity to understand why this data is important. We're working with health, we're working with financing, metrics, how we can measure different ways of how important the costs sometimes of these opportunities, but then how data can help us understand. Just to finalize, I mean, this is again a bit more about broader, not only to make a reporting process, but it's really at the project level, how we're really using and the demonstrating the need for a right and actionable information. For example, to understand project precipitation for coastal adaptation in many countries is just an example in West India, and how we can bring data and information to assess sea level rise, flooding areas, understand how urban areas can be impacted, understand, for example, the seasonalities of this, that can happen only when the most rainy season is the summer season. So really understand for practitioners and planning developers that they need to think maybe actions that are maybe applied only a certain month of the year, or how to mobilize populations, and what decisions need to be done now, what decisions need to be done in 5 years, and what decisions need to be done in 30 years. These are the type of processes, and what are the indicators, what are the monitoring process that they would need to have in place, what is the institutions and governance, and what data and information they would need to have to actually make those plans. So who do they need to partner with? How can they bring more information? These are all the type of work that we're doing. Just another example, this is in Ethiopia, really to understand the heat waves, urban. So it's really talking about extreme heat conditions, so very specific, tailored climate variables that is very important. So we also try to educate in the sense of we don't need to work about only one type of average temperature of one country, but it's really understanding what is important. So this is the night temperature, maximum, minimums, averages, and I'll let Mackenzie really get into that information. Lastly, for example, one of the issues that we've been having is resolution, and a lot of the lack of data and information to understand adaptations in areas such as the small island developing states. And so we all know that many of these countries have limited observational data. As I mentioned, the lack of the understanding of bringing that data into decision-making processes, how to really understand all the dynamics and physical dynamics are happening in there, but are additional aspects that you need to take into account to understand overall risks. And also, of course, the resolution, I was saying, in small islands is very difficult to really bring a resolution of all these models. So what are the options that we have, how we can do some assessments based on what different data sets. So I'll stop here. So we hope to give a little bit of time then for the questions. And then this is just the site. We'll send all these links and information for the whole team to have, and you have any questions, and I'll pass it to Mackenzie. So I'll stop sharing here, and if you have any questions, please feel free to ask. Thank you.
Thanks, Anna. Everyone, I put a link in the chat, and so if you have the opportunity or have a laptop with you, feel free to play along with us, and so you can get comfortable and experience the site. My background, I will say Anna brought me into the bank. She is the one who started the Climate Change Knowledge Portal. And so those brief 11, 12 years ago, how time flies, but this was all her brainchild, and we can see how it has grown. I work on translation of large data sets on the climate side into usable, manageable products. As Anna mentioned, the Climate Change Knowledge Portal really tries to give our teams and our clients the foundational data so that when you're doing an assessment, it's easily accessible. You can plug it right into an assessment, and everyone is working from the same foundations. All the data is accessed. Everything is gridded, right? Is latitude, longitude gridded, but we push it through country or watershed focuses. And so really you can select any country. If you're interested in watershed, you can look at the watershed, and these are different application oriented. For today, we're really going to look at Cambodia, and how the site is designed is it increases in sophistication as you move from left to right. And again, this is meant to support risk screening, economic functions and diagnostic tools, and various assessments, such as informing policy decisions and policy planning. And so really what we've done is we give everyone kind of a country summary where you're able to understand your historical climate, what happened, or what is the specific situation that you are working on and that you are dealing with, and how can that be informed as we move forward. What we're able to say is we have a seasonal cycle, so you can get a brief capture of what's going on in terms of the rainy season, various different heat thresholds, and everything. We can see the longer term time series. We offer a range of different historical data sets, CREW, which is station-based data, and ERA 5. We're also working in the middle of processing ERA 5 land, which is at a tenth of a degree, so about 10 kilometer resolution. So we're continuing to increase and improve and update as we move forward. You can also look at, mean climate, so the average and the trends over time, or we can actually look at natural variability and how are things changing as we move forward in time and as we move. What is the date today? August 26th. Not every August 26th is the same in the historical record. How did it change year on year? How were long-term decadal trends influenced as we move forward in time? Was there a specific event that happened in your area that you really want to focus on? And we offer a range of ways to look. One interesting thing, if you're looking at Cambodia, if we look here, we can see the historical record 1950 to present, but you can see these trend lines, 1951 to 2020, 71 to 2020, and 1991 to 2020. We can see the angle of change and the pace of change is becoming more rapid. So not only are we seeing increasing temperatures, but the pace at which increased temperatures, and in this case, heat indexes, absolute temperature and humidity, how that is changing as we move forward in time. Something to really understand, and we recommend teams get a really good idea of the changing conditions. And there's a variety of different tools to understand, because change, and this is unique and context matters, change is change from what? So how do we actually know that as we're moving forward and as we do these assessments and diagnostics? So here we look at mean projections. As Anna said, we offer the range and suite of future climate scenarios. These are identified and determined by a global body that is, many international research institutes across the world over are contributing to this and adding data and expertise. This is the information that underpins the IPCC assessment reports. And it's these future pathways that inform what type and pace of change you would be on. So, shared socioeconomic pathway, and a range of the numbers at the end are essentially the radiative forcing per meter squared, but that is essentially the additional amount of energy put into the atmosphere by 2100. How would a specific area change? We're working on today, if we do our assessment in Cambodia, we're looking at 370, and we'll look at end of century. We can understand there's a range of different indicators that you can see both for temperature and precipitation. And so we can really understand not just average temperature, but we can understand temperatures at a different threshold, different types of temperatures, the maximum of a daily heat, the minimum, and the different thresholds at minimum. This has implications for agriculture. It has implications for energy demand, both during the day and at night, and energy supply services. And certainly human health is always a big consideration when we're looking at risk and needs and gaps in an existing system or service delivery system. We can also look at anomalies, or you can look at the new normal. In here, this graph, we can see the historical period is identified in this gray line. And by the end of century, under this scenario, you're seeing a new normal. This is a jump 2, 3 plus C year wide. And we can see in the summer season, it also jumps and gets hotter. What does that mean when we're looking at, a heat index at a certain threshold? How does this change, right? We can really see the spike. So by the end of the century, number of days that surpass 37 C temperature and humidity, and that is above the body's natural cooling threshold. So if you step outside, your sweat does not cool you down as it is meant to because the air is so humid and hot. Anyways, you can see in the historical record, never really experienced, maybe a couple of days over March, April, May. But now we're seeing almost saturated the full month, 30 days. So you have every day is surpassing these thresholds, and the time that it is even greater. So, I mean, you can start to understand risk. You can start to understand change in these ways. We can really see the presentation here when we look at months over decadal change, and again, the long-term time series. If you wanted to dig deeper and really look at what the individual models are saying, and much of this work was used in the CCDR reports that Anna mentioned. These are, where do the specific models land and how are they representative in the multi-model ensemble? Some very extreme models, should those be included in your ensemble, right? You can really understand the range and what is fit for purpose, what is really the best use, and how do we understand multi-model ensembles and the dispersion of individual models. We always recommend teams use the multi-model ensemble unless they have a specific need or a real understanding of the underlying assumptions and caveats and biases that might be in a specific model. These give you different correlations, so you're able to see both on historical and in projections how they interrelate and the correlations between temperature and precipitation. And you can do this again across a wide variety of indicators. We also can give you trends and variability within future climate. So how is it going to change? And again, climate is not a straight line. It moves up and down. You have colder seasons, warmer seasons. You can have colder, warmer seasons, warmer, cold seasons. How do we actually understand change within, and change that is statistically significant within these changing natural cycles? And so here we look for the same thing as a historical. I'm sorry, I see our maps aren't presenting tonight, but I will have that fixed before. As you plan it more. Anyway, we can see the change in dispersion of temperature. So again, here's your historical temperature, and if this is just average mean temperature, we can see from the different periods: 2020 to 2039, 2040 to 59, 60 to 79, 2080 to 99. You're seeing a real jump in changing of just average temperatures and the distribution of the temperatures that are surpassing these thresholds. So what does that mean for risk context? What does that mean for gaps in service delivery, or where investment in specific infrastructure needs to be made? Again, if we're looking at the maximum of the daily maximum temperature, again, where is the largest change? We're all seeing the largest change in terms of standard deviation is as we move towards the end of century. And so all of the hottest events as compared to the historical reference period are happening as we move forward in time. And again, we can see a long-term time series. We also offer specific opportunity to jump into specific types of risk. And here, one of our most popular, I think, tools is how we put together compounded risk. So, and if you think about it, it makes sense. The hottest peak of the day doesn't happen in a vacuum, right? You also will experience the temperatures as they get warmer throughout the day, the morning into the peak afternoon. You also experience change in humidity. You might have also had a warmer night. How does this compounded 24-hour cycle of changing heat impact the body, and what does that mean? And here we actually could see specific areas where we have hotter and less hot when we're looking at temperature-based heat plus population as a risk categorization. So we made an index of multiple types of temperatures and humidity conditions, and then overlaid it with populations. We get this question a lot from our clients of, okay, it's very, very hot here. Do I have to invest if nobody lives there, right? Why would we do that? And so this is a way to say, okay, this is your most densely populated area. This is where investment should be made. And, and this, it's a pretty basic risk index, but you can have a very, extreme heat. And if no one lives there, shouldn't be investing. You can have high to moderate heat, but if it's your most densely populated area, there's a higher risk, right? And so that's kind of these tools that have been easy for policymakers to grab. We can also see the change in these cycles. If we look at early century all the way to which times of the year are really going to pop. We're also able to look at different thresholds, right? And so again, by end of century, we can see 30C, you're pretty much maxed out. As we get to the higher thresholds, not every day of the month, but we can see these real spikes, and where Cambodia is often seeing its hottest season, but it's these thresholds that are new normals, if you will. And again, we disaggregate this. We can see, you can see the projected populations for each future climate scenario, plus, you know, what this looks like in terms of aging populations. And so then consider that when we're looking at heat as this broader package. And finally, sea level change. This is through a partnership with with NASA's sea level change team. And so this is some of their latest data. We can see the global time series that will pop up in a minute, but we can see the monthly change and the monthly anomalies as from 1993 is when this satellite mission first started collecting this data. But really, you can see a pretty significant increase in terms of global average mean sea level change from 1993, and 1993 is treated as the zero here. We can identify this through tide gauges. And again, if we're looking at just Cambodia's specific exclusive economic zone, we identify this in terms of not just a country, but we just want the coastal area. And so each country has an exclusive economic zone, and so that is how we aggregate this. But we can see the seasonal cycle, which could be influenced by ENSO events and other tropical storm events. And then we can see there's a real variability in terms of the annual cycles, but the rise is increasing. And so something to consider if you're looking at historical sea level change for a delta or a coastal area where you're looking. Again, you can see the contributing factors. And interestingly, this product, which shows you the flood days, so there are thresholds in terms of how many days per year from 79 to 2015 increased over 40 centimeters, 60 and 80. And so we can see these thresholds, right? So number of days where we had a high flooding zone, and what does that mean? And if you look at the projections, you can see these really start to increase when we get to the end of the century. If we're looking at projections, we can now, again, this would be, you can look at this globally, or we can look at Cambodia's specific exclusive economic zone. So we can see the rise and the potential, meters in change as we get to 2100, 2150. And we can compare this to global. Finally, we can look at the different milestones. So if you're interested in the meter rise, so 0.3 meters, when would that happen and under which scenario for my area? So again, if we're looking at Cambodia, you can pick any country or any coastal country, and we can start to see when these changes start to shift. And again, the huge error bars. And so this gives us an indication of the confidence levels and the large uncertainty that we have on some of these projections. And finally, we can see the contributions in terms of year, or we can see the process, and really what is really driving increased increased sea level around Cambodia, and it's all thermal dynamics. This is sea level rise, increasing water temperatures, increasing melt, warmer water increases, and so you're taking up more volume, especially as warmer water warms from the deeper ocean. It rises to the top, in addition to a sheet melt off, right, which we're seeing in Antarctica, the glaciers in Greenland. And finally, what I think this group of experts assembled in this meeting would be interested in is looking at tropical cyclones. We offer this historical, and this historical model is from the Columbia's hazard modeling team. And what we're really able to see is the tracks, right? And so we can see the number of historical tracks by tropical storm and category 1, 2, 3, 4, 5, and understand where that kind of hit per year and how many you're dealing with. And then we can also look and not only at exclusive economic zones, but we can see the ocean basin. And if you think, a tropical storm or a cyclone develops out of an ocean basin, and it might transfer into one or two other exclusive economic zones, and then it may make landfall, not always. And so this was a way to really give insight into the number of storms. And again, it's 1951 to 2014, how many storms and which category of strength for the ocean basin, what number came into the exclusive economic zones, and then from that, what number hit landfall. And so that it helps us understand the numbers. And again, if you're looking at an economic analysis, historical information is always really key. And we can also see the seasonal cycle. Finally, in projections, we're able to look at the same ideas, but we can see where's the projected change. And so you can see this global, we can see the ocean basin and Cambodia's EEZ and landfalls. It kind of are the numbers of storms changing, or is it actually the intensity that is changing? And again, we can show it here, the relative frequency, and then again, this is the data table. Final thing I wanted to highlight, as I know we want to leave some time for questions, is how do you get access to the data? So we have made everything that you see here that's presented on World Bank site is really accessible. We offer spatially aggregated, so if you just want information for Cambodia or a subunit of Cambodia, or if you want information for the whole globe or specific ocean basins, if you wanted East Asia and Pacific region, every country in that, you can just download that. So it's really tailorable to what you would like to choose. We can select our country, and then you're able to go through and select from a range of different future projections data sets and historical data sets. You can select every indicator that we present. Everything, again, I said, is always put online. You can tailor it. You can take every SSP. You can take one. You can take different parts of the ensemble. You can have individual models, etc. This is all available as an API, CSV, or Excel file. If you want the raster files, which are the geospatial data, we have over 110 terabytes of processed products. And so again, this is time series, climatologies for every time period that we offer. We have standard deviations. We have heat plots. We have extreme event. You want the tropical cyclone data. All of that is available. You can access it here if you are going through a terminal. So I would say a developer would want to access it that way. Or we can look directly and download the files yourself. If you want daily data, we have all of it here. The daily data, one time series is looking at about, I think it's 15 terabyte. And so, each model, you can take that. So it's a huge wealth of data that we hope puts people in a position to prioritize their resources and expertise. You don't need to process all of the raw data. Maybe you spend your time and expertise investing in adding value to the data that's already processed. If you want to look at a specific area, it supports your specific research or your specific, sector implication. And so that's what we're really trying to get through. Grace, I know there's only about 5 more minutes.
Yeah.
Anyone have any questions?
Very quickly, Mackenzie, if you want to show the country profiles, so they can find.
Yes, thank you.
Just where the summary of this.
Yeah, and so here, if you wanted to look at a summary of a specific country, these country risk profiles. There's a huge range. And where are we? So here's Cambodia is a recent one that we have finished not too long ago. And we continue to add on to these if there's a specific request for a country. We have another, I'd say, 15 to 20 plus that should be published anytime now. And we're continuing to work on another 10 over the next couple of months. So I think several more are coming. We always continue to update. But you can find that up here, download data, country profiles. Our metadata is here, a kind of user manual, a guidance note of how really should we be interpreting and working with historical data with these, within this data set. How should we be interpreting and working with projection data? What are some use cases and kind of do's and don'ts that we've had teams ask us or that we've seen happen? And it's kind of a general resource guide. So with that,
And just to say that a profile is a Word document. So it's not all that, it's a summary of all that information. I think that might be handy as well.
It is a PDF, and so you can see high-level synthesis, and you can have the data and graphs, maps, visualizations, etc. Yeah, thank you, Anna.
Yes, thank you very much.